They
At
buy
auction?
it. No, they buy it. They buy it from different, usually from customers. This is our side here. This is our scrap on this side. Just every bin's a different scrap, like a different grade of scrap. And we have what they call an ABS, an alloy blending system that tells us, you know, take 10,000 out of there, take 12 bales, take so much loose scrap, and it blends it and comes out close to our alloys.
This is all industrial scrap.
Yes, this is all mostly from extruders and stampers. You can see this is from stampers.
So it's not contaminated. You're
No.
getting it from somewhere that you
Yeah.
know where it came from.
Right. And it all comes in, and some's mixed. Like this pile is a 60-61 and a 60-63 mix. That's the alloys that we use. We have some painted here. We're commissioned to paint, do 15% paint, and that's all we're allowed through the EPA. We have a big scrubber on the back that scrubs it. When we get to the saws, you'll see the saws. These are just the ends that we saw off that we bring back and remelt. When our furnace helpers get their pick list, they load it with the front loaders and fork trucks, whatever it takes, and it loads into here. This is our cart, and one guy will load, and up there you can see there's a podium up there, and it's automatic. You hit a button to melter 1, melter 2, it goes there, opens up the door, and this slides out, and then there's a pusher that pushes it into the melter, into the furnace, as you will. So we use this extensively all the time. So they'll put whatever it is, it'll hold up to 30,000. That's the max limit on it. So. This is what we call melter 1. This is where all the melting goes on, right here. Load up the cart, bring it over, door comes up, pushes it in. There's controls on it. You can change the heat and how hot it is. But all the melting is done here.
So when you make your mix,
right,
you put it here.
Right.
Now you got virgin over here.
We use, yeah.
So they come together?
Yeah, sometimes you have to use sows. It calls for that.
And then how do you get those in the oven?
We either put them on.
Put them on here.
What you try to do is build a base down so it don't splash. So once you put your base down, then you can push them on so it doesn't splash. And they're dry and they're at 500 degrees, so they don't take long. But once it's melted, this particular furnace or melter is 105,000 pound capacity. Okay, so once it's melted, we take a sample. We see, and I'll show you. There's spectrometers that you lay the sample flat, put it in the spectrometer, and it tells you where you're at on your alloy. It's pretty nifty. But once it's melted, we'll take a sample, we'll lathe it, test it, and then we get our alloys ready, okay? And then we bring it over here. This is called a holder. You can come this way. There's two different kind of temperatures you run. You run a roof temperature while you're melting. Once it's melted, you go into a bath. So a big thermocouple goes in and measures it. Usually running at about 1,000 degrees Celsius on the roof, and then the bath about 700.
You're just holding it until you can extrude it? Is that the...
No, it melts here, and then we get our alloys ready, and then this furnace actually tilts up. It tilts really far, runs down the trough, okay, and into the holder. This is where we hold the metal before we cast it. So you alloy here. You put your alloys in here, you stir it with the stirrer, and take another sample, and if it's good, then you cast it, and we'll get to the casting table here. But this furnace tilts forward, it runs down the trough into here. No, it's right here. Well, it goes in, you can look. It goes in 5, 6 feet maybe.
Yeah.
Didn't they have to dig pits like 75 feet down?
That's over here.
I'll show you that. That's at the casting.
That's where they're casting.
When they open this, there's a pool down there that they're stirring that thing.
Now, in this, the metal is at the bottom of this, and then it comes up to probably here.
Our Swiss cheese.
But it does get hot back there.
I don't know how you guys do it.
So this is 105,000 pound capacity. This we call melter 2.
You take that out of the pipeline. You put it right in, or you put it on the sled and into it?
We put it on the sled and put it in. Forklift it on there.
Did you do it from the backside, or do you have to come around?
Well, you grab them out of there, come around, put them on. This is melter 2. It's a little different. It's 190,000 pound capacity, and it basically gets loaded with us, and on the outside you can't see it, but we dump truckfuls of chips. The chips come through, come up, dump in there, and they're heated. So when you heat them, they dry, and there's a shaker, it sprinkles down in here. This one has a stir in it, but it's an electronic stir, so it creates a field. So if I open up that door, the metal in there is going like this. This one actually has a mechanical big pump in it, and it stirs it, so when them chips fall in, it melts them, because chips are light, and if you don't get them in, they'll burn. So this is 190, because you always have to have 80 or 100 pounds in there for them chips to fall in and melt.
This one, is this a continuous caster then?
The continuous caster is right through there. I'll show you when we go around. But it gets same
Get
thing.
this metal from both furnaces?
Yeah, one at a time.
One at a time.
One at a time. This one does not tilt. There's a pump that pumps it into our holder. We're going to go around and see holder one. This right here is, we use this for a skimmer. When you melt aluminum, sometimes it gets dross on it, and this comes over and they skim the dross off the top of the aluminum, which you've seen back there. But the truck will dump the chips outside. It comes up the conveyor, over another conveyor, comes down into here, and then it starts drying them and shaking. Then they fall in the furnace, about 10,000 pounds an hour. This is all systems, same thing. It's all with the chips. This is our holder too, so when we come over with metal, it sits in the holder. We alloy it. I told you about the spectrometer room. Right back there is the spectrometers back there. That's where we test everything. They're going to open this up for you. But these holders hold about 100 pounds. That's a stir.
I was looking for it.
It was no crane. But if you look in there, and it's full of aluminum. You can see the aluminum on top. So yeah. So this one actually tilts too, and I'll show you when we go up there how that all works.
How deep is that, Jeff?
Probably 6-7 feet, but it kind of goes like this, and then it bottoms out. You can see when it tilts, it goes out through there. So it tilts up, it's all computerized. This is the casting table. This is what we make right here. This is the billets. So it's in the holder. It gets to a certain temperature, it reads it right off the board, the top right-hand side. When it's to temperature, it's all computerized. This is from Wagstaff. It's called air slip. It gets it in air slip. That makes it real pretty. It comes down. This actually folds down, and there's starting heads down there. And the metal flows out through into the table, and it's all computerized, and it's all timing. And the molten aluminum goes down through there. Water hits it, cools it, and it just continuously passes down. And when it's done, then you clean up. The table slides up like that. You bring your billets up. This is how we move them from there. We call this the lay down table. So you pick this up. This is the only crane. Bring them over here. Set them down on the lay down table. We have, this, we have a 7-inch table, an 8-inch table, a 10-inch table, and a 12-inch table. The 7-inch we cast 90 logs. The 8-inch we cast 68. The 10-inch we cast 44, and the 12-inch we cast 30. It's all due to weight.
Yeah. And then you just pull them out of there, lay them on the table.
Pull them out of here, lay them on the table. Everything's computerized. So my crane guy puts them down. You go hit a button, it moves them down. Comes back over, grabs another one, comes over. You know.
It's amazing how it used to be.
Yeah.
Just amazing.
It's beautiful.
Talk a little bit more. That plate is like this now when you're molding.
Yes.
And you're filling this with aluminum. So that's like a table that's getting filled with aluminum.
Yes.
Now, tell us a little bit about how do you maintain that where I know you've got a plate underneath that pulls it down, or at least it drops down.
It's all computerized.
It's all gravity though, isn't it?
No, it's all computerized. It's actually pulling them, and it's all fed by the computer.
It is pulling.
It actually almost
There's nothing that controls the size
Other than those holes.
Right, and when it comes down through there, massive amounts of water are hitting it and pulling it right
underneath.
away. Right.
Not on top, but underneath. Yeah, when they explained that to me, I couldn't believe it.
This is our 7-inch table, so there's 90 logs within. And we have an 8-inch table at 68, our 10-inch table's 44, and our 12-inch table's 30.
So
That's the count.
These are finished product that you
That's
see hanging
finished.
there?
Well, no, it has to be
I mean, you got-
homogenized.
I understand, but this is what goes on the table.
Right.
Not nothing like that.
Yeah.
It's amazing. What temperature is it when it comes out here and goes onto the table?
Oh, it's cool.
It's been hit with chilled water.
Yeah. You can touch it when it's coming down out of there. Right?
Now, do you have a closed loop system, or are you going straight to drain?
It's closed loop. Yeah. We got a big water facility.
I thought at first
No.
I thought, wow.
Comes down, and then it keeps working its way down pretty quickly too. Comes down here, and it goes across to the other side.
Okay, now see this shape right here.
Yeah.
That's the bottom plate that's taking it all the way
They
down.
call that the stool cap.
And when you have that, is there something sucked on that's pulling?
No, it just drops.
It's gravity then.
Well, yeah, it's controlled by the computer.
Okay. We have
goes-
gravity and we have computer.
It goes down. That's a UT tester, so it checks it for cracks. See it right here? Here, we can see it better over here.
what, X-ray?
Yeah, it's like a sonogram. Checks it for cracks. It goes over to the other side and it stacks it automatically, as you can see when we get down here. This is the crane for that. It stacks it.
100% checking that for cracks?
Yeah.
Every roll goes through there.
Depending on what the customer wants, yes.
Wow.
And there's 4 homogenizers. 2 here, 2 down there.
Explain homogenize.
It's like a heat treat in steel termination.
Okay, so then what it does is it
Heats
just
it up and makes all the particles come together.
Gotcha.
And then it has to go from the homogenizer to the cooler, which are the blue ones. And it has to go in there in a certain time frame, or it cools down too much to where all the molecules start to go back apart. After it's homogenized, it comes out and comes to our saws. We have 3 saws. We have this saw here, band saw. It's for the rim industry. So it saws them in 10, 12-inch increments. Has a robotic arm on it, grabs it, brings it over, puts it on the pallet. Just keeps going. Zing.
These are it right here.
Yeah.
They don't call them pucks, do they?
No, what they do is they heat them up and stamp them and make rims out of them.
Like truck rims?
Yeah. And then these 2 saws are for billets and logs. We cut. Some customers want them cut, and some customers have their own way to cutting. Automatic banders. So once it gets full, the bander moves down to track, bands it, pick them up with a forklift, take them to the back. Huh?